Alright, hi guys. Happy Tuesday if you're watching this on Tuesday. This is the video for April 14th. We are officially going to start new material today, so we're going to jump into Unit 4. Today we're just going to take some notes. I'm going to give you an introduction, and then your daily assignment is just going to be a little quiz over the notes. So I want to start with a couple of announcements first. Yesterday I had you guys try to upload a photo. I really just wanted to see who was able to do this, who was not able to do this, what kind of issues we ran into. So I appreciate you guys. Those of you, lots of you did it. I loved seeing your pets. Wow, that was great. So I appreciate you guys doing that. Just like a little bit of background on that, because I had some questions. This came from the math department. So this was like something that came from my boss and some of the other math teachers. We were discussing, how are we going to check the kids' work? And the general consensus was that the easiest way for us to check your work would be to actually see a photo of that work. This won't happen every day. I don't need to check your work every single day. But if you guys remember back to the very, very first day of our online class, I told you I was looking for a couple of things like participation. Are you participating? And then at some point I am going to have to check your accuracy, right? Like a formative or a summative. This is when I would be asking for the photos. I don't necessarily need a picture every single day, but in those times where I am checking for your accuracy, like on a formative or a summative, this is when I would need the photos from you. And I obviously know that not everyone is able to do this. Not everyone has the technology or understanding or whatever to do this. Just politely let me know. Sending me like a crazy email or an angry email is not a good way to get help from me. Just politely let me know. The whole reason I did the assignment yesterday was to figure out, who needed some extra help on this or who was able to do this or not. So that's the deal with the photos. So I appreciate those of you that did it. If you're having trouble, please just add a little comment or send me an email or something to let me know. And then you don't need to do this every day. I'll put in the directions, hey, I need you to include a photo on this. I'll make it really clear when you need a photo. The other thing I just wanted to touch on really fast is your grading. So far, everything has pretty much been completion and effort. Like if you turn it in, you get the credit for it. We will get to a spot where I need to check accuracy, so just pay attention to that. And you need to give me something to base your final grade on. Because we're on a block schedule, we can't really just use the third quarter grades because it's only the halfway point. Schools that are not on a block schedule have been in class since August. We have only been in class since January, so you really have only gotten through half the class. So you guys have to give me something in this fourth quarter to base your grade upon. If you're not doing anything, then when May rolls around, I don't have any way to prove that, yes, this student deserves a passing grade. So the way you earn a passing grade, turn in your daily assignments and then making sure we're looking for that accuracy as well. Communicate with me, just let me know. You guys will get a little mid-quarter check-in to let you know if you're on the right track or not. So we'll talk more about this, but please, and I know there's a lot of conflicting information or confusing information going around. Please don't think that you can just blow off the fourth quarter. I know most of you guys are not doing that, but if you are considering the fact that you don't really have to do anything the fourth quarter, that's just not true. So please make sure you're giving your best effort. That's what we're looking for, is just an honest effort here in the fourth quarter. Okay. And you guys have been doing a great job so far, so I'm really super proud of you guys. Okay, so agenda for today, we're going to do just a really quick Unit 4 introduction, and then I have some notes on a few different topics. So I would definitely be copying this stuff down. If you have a notebook at home or some paper at home or something, this is just kind of a notes day for us. So we're going to start a brand new unit. So this is new, fresh start, everybody on the same page, brand new information, day one. Here we go. Okay. So Unit 4 is all about radical functions. So far we did linear, we did quadratic, and then we did polynomial right before spring break. So now we're going to jump into radical functions. This is another shorter unit. It only has 2 sections. So we'll do a solving section where we're using those opposite operations to isolate a variable, find its value, get x by itself, all that stuff. And then we have a graphing section as well where we're talking about key features and transformation. So this is what you can expect for Unit 4. It's going to be a little bit shorter. This is a pretty easy unit actually, so it's a good one like for our first unit to be online. I'm glad it's this one because this one is a little bit easier in comparison to some of our others. So defining a radical function, it's important to know what a radical function is because there are some functions that look like they might be, but they're not. So a radical function is a function where the independent variable, or x, is in the radicand, okay? So the x has to be in the radicand, and a radicand is just whatever is underneath the radical sign. So this is the radical sign, so you're going to see these a lot, the square root thing. The x has to be underneath. It has to be living in here. This is where the radicand is. So here's a couple of examples for you. These on this side, over here on the left, these are radical functions because if you look in the radicand here, so for our first example, our radicand, right, is whatever is underneath the radical sign. In this case, it's x minus 1. This x has to be underneath this sign here. So if you look at this one, for example, this list over here, the x is in the radicand, the x is in the radicand, the x is in the radicand here. So they're all the same in the sense that they all have x living underneath this radical sign. Over here on this side, however, if we're looking at our radicand here, our radicand is just a 4 here, and the x is on the outside. This is not a radical function because the x is on the outside. Okay. This one, again, our radicand is 3 minus 7. This is not a radical function because the x is living on the outside, not allowed. Okay, so this is something different. Same thing here, as like complicated as this looks. If you're looking here, this independent variable, this x, is not in the radicand. Our radicand is just a 14, so this is not a radical function. So just pay attention to that. The x has to be under that radical sign, the square root sign. The parent function, so the simplest, the most basic radical function that we could possibly have for this unit, this right here is our parent function. So f of x equals the square root of x, or y equals the square root of x, either one. Okay. This down here is the shape that our parent function makes. So this is the most basic radical function in the entire world. It is as simple as it gets when we're talking about the radical function family. So if I were to ask you what is the parent function for radicals, you would say f of x equals, or y equals, the square root of x. It's this one right here. Over here I just included this little table of values as well. So basically, if you look along this graph here, along this curved line, so you can see it's a slight kind of curve here. If we were to just plug in these x values, right, to our function, we'd be plugging them in here for x. So if I were to take 0, for example, and I were to plug in 0 here, the square root of 0 is just 0. So that's how we get this point 0, 0. When we plug in 0, we get a 0 out. Same thing here. When we plug in a 1, we're just plugging in, right? The square root of 1 is 1. So that's how we get this point 1, 1. If we plug in a 4, the square root of 4 is 2. So we're plugging in for x and we get 4, 2. If you look over here, right, if we plug in a 9, the square root of 9 is 3. So that's how we get this like slightly curved line like this. If I were to plug in a 2, right, the square root of 2 is like 1 point something something. There's not a whole number, but it's that decimal living right in there. So this curved line is your parent function, the most basic, easiest, simplest radical function in the world. We also have a standard form for our radical functions, just like we have standard form for quadratics or linear functions, right? Y equals mx plus b, y equals ax squared plus bx plus c, right? Standard form is just how we organize those functions. So that's what this is over here. So the way we organize radicals, standard form, a times the square root of x plus c plus d. So this is how we organize our radicals. A is being multiplied on the outside here. C is being added or subtracted on the inside, so C also lives in the radicand with x. And then D is just being added or subtracted on the outside. So A is being multiplied, C is being added or subtracted, D is being added or subtracted on the outside as well. If you would like to learn about B, there is a B value. You would have to take a pre-calc or a trig class. B actually lives in front of x right here. We don't do that in this class. It just adds a little bit of extra confusion to the graph. But if you would like to learn about B, you would have to go take pre-calc and trig. That's why it goes A, C, D, is because we in this class skip over B, which actually lives right in here. So A being multiplied, C being added or subtracted, D being added or subtracted. Okay. And then the last section of this is all about graphing and key features. So you're going to hear some new key features in this unit. So we'll stick with vertex, which we did in Unit 2, but we're going to add in domain and range. And we'll talk more about that in this section. And then we're also going to talk about transformations. So a transformation is just a shift or a change from the parent function that we can write out in words or we can calculate from an equation. So I gave you a little example over here. This black line right here, this graph, this is our parent function, right? This is the original. This is y equals the square root of x. This is our basic, right? 1, 1, 4, 2. Over here would be 9, 3, right? This is our parent function. This red graph, this is still a radical function. If you notice, the shape is pretty much the same. It just flipped upside down, right? It moved a little to the left and it moved up. So a transformation here, that would just be the changes that you see. So this red line, for example, those transformations are a flip, a shift to the left, and a shift up. So we'll talk about those transformations as well. So vertex, domain, and range, transformations, the shifts or changes from our parent function, that is the second section. There's only two. The last section of this unit will just be finding those key features and transformations on our graph. Okay. So that's all I have for you today. I just wanted to give you a quick overview, give you some time to take notes. You should write that stuff down. Please, keep a notebook or a binder or something, whatever you have, similar to what you would do in class, because we will come back to this stuff. We will do final review of everything before the end of the school year. So try to stay as organized as you possibly can. Try not to lose stuff. You should actually be taking notes. Write this stuff down. The more you write things down, the more likely you are to remember them. So treat this just like regular class. The good news is it's just a lot shorter. So let me know if you have questions about any of that stuff, but once you get through this video, head over to Google Classroom for the daily assignment. It's just a little quiz on the notes and stuff that I gave you in this slideshow and this video. So as soon as you're finished, you guys can head over there, and I will see you all tomorrow. Thanks, guys. Bye.